4.3. Remember, we are in the chapter that we were dealing with exponents and logarithms. So here are our objectives for 4.3. Okay, we're going to use the product rule, the quotient rule, and the power rule. And I don't think we actually used those words in Algebra 2, but it was pretty close. I don't know if you remember this that we made, our exponent foldable. You remember this? Okay. The three rules that we're going to use are on here. We call them the product of powers, the power of powers, and the quotient of powers. So you already know them. You've seen them. They're called a different thing in this curriculum, in this textbook, just so you know. Okay? So you have seen them. You saw my tomatoes. So you have... Whoa, what are you doing? That was weird. Just like zoomed in really fast. Settle down. Document camera. Okay. So power rule, quotient rule, and product rule. And then we'll remember how to expand logarithms and condense logarithms. And then the ever popular change of base formula. It was what's that word? A bit sarcastic, because it's not popular because we don't use it anymore because our calculators do it for us. But I have to teach it to you, so I will, because I'm going to follow directions. It's fine. Yeah, okay? So, product rule, okay? Here's what the product rule says. So if we are multiplying like bases, what do we do with our exponents? That's the product rule, okay? The thing about exponents is that, if you'll remember, because exponents and logarithms are so closely related, in fact that they are inverses, the exponent rule that you know will help you remember the product rule for logarithms. Because it looks like this. Log base b of m n equals the log base b of m plus log base b of n. So if we're multiplying like bases, we add the exponents. If we're multiplying inside of a logarithm, we add them. Does that make sense? Okay. The exponent rule that you know looks like this. When we're dividing like bases, what do we do with the exponents? We subtract. So that was called the quotient rule. Quotient meaning divide, right? So the quotient rule for logarithms looks like this. Log base b of m over n is log base b of m minus log base b of n. Pretty straightforward, yes? Okay, and the last one is the power rule. Okay, the exponent rule that you know is b to the m raised to the n power. When we're raising a power to a power, what do we do with those numbers? Multiply, right? Okay, I'll even put a dot in there to help you remember that means multiply, if you can even see that dot. Okay, power rule for logarithms. Log base b of m to the p power is p log base b of m. So what did we do with that exponent inside of a logarithm? We moved it in front as a multiplier. So multiplying like bases, or excuse me, power to a power, multiplying, we multiply those exponents. If there's an exponent inside the logarithm, we bring it down in front as a multiplier. Okay? So that took care of the first three things on our list. There's our list. Product rule, power rule, and quotient rule. So we need to remember about how to expand and condense. The good part about expanding and condensing is they're kind of like opposites of each other, right? If we can figure out one, we probably got the other one okay as well. Okay? So, what if I ask you to take this logarithm, log base b of x squared, square root of y, and expand it. And expand it. Well, if I'm expanding it, how many times am I writing the word log? as many times as there are terms, right? So in this case, twice, right? There's an x term and a y term, so I'm going to have log written 2 different times, one for the x and one for the y, okay? So I can start out, well, these two things are being multiplied, so when I expand them, what do I do with them? Add them, okay? So I have log base b of x squared plus log base b of the square root of y, okay? Now, is that as simplified as it could possibly be? Well, I have an exponent inside my log. Can I have that? So it goes down in front as a multiplier, right? Good. So 2 log base b of x. What about this one? Is that as simplified as it can get? I'll tell you this. We do not like to leave roots inside of logarithms. We don't. Okay? Exactly, right? When we take the square root of something, that's like raising it to the 1/2 power. So this is really like log base b of y to the 1/2. So would it seem logical to you that I bring the 1/2 down in front as a multiplier? It would. Excellent. Okay. So plus 1/2 log base b of y. Is that as simplified as I can get? Are you positive? You should be. It is. Okay. There's nothing else inside the log that I can pull it out as a multiplier. There's only one term inside of each logarithm, so I can't expand it any further. Does that make sense? Okay. So let's try this one. It's going to be super fun. So how many times are we going to have the word log written this time? 3, right? One for the y, one for the 36, and one for the x. Okay? So let's start with this. Log base 4 of the cube root of y. We're just doing it slowly. Is that okay? And then what? Minus, exactly. So I have 2 things that I could do. Okay? I'm subtracting the whole denominator. If I'm doing that, I could do this, right? Log base 4 of 36 plus log base 4 of x to the 4th. Is that the only thing I could do there? Or could I write log base 4 of the cube root of y minus log base 4 of 36 minus log base 4 of x to the 4th? It's not that I'm dividing it again, it's that both of those things are being divided. And if you think about it, if I distribute this negative to each term, isn't that what's happening anyways? Okay. So I do want to do that for the record. I want to distribute this negative sign. Okay. But as I do that, I want to simplify as I go. Are you okay with that? Okay. So what's happening here? To the 1/3. So 1/3 log base 4 of y minus. Can we simplify that at all? No, I can't. Log base 4 of 36 plus, oh, pardon me. Thank you very much. Minus. Good job. Very good. 4 log base 4 of x. Excellent. Good catch. No, I did not. I very rarely do stuff like that on purpose, and if I'm going to do it on purpose, I tell you I'm going to try to trick you. But sometimes I'm a human and, well, all the time I'm a human and sometimes I make mistakes. Okay? So, do you feel comfortable expanding logarithms? Okay? What about condensing? If you can expand, you should be able to condense, right? So, log base 4 of 2 plus log base 4 of 32. How many times do I write the word log if I'm condensing? 1. Log base 4. Of what? 64. How'd you get 64? 2 times 32. I'm adding my logarithms, so what do I do with their arguments? I multiply them. Okay? Now, is this simplified as far as it can go? It is not. Do you know why? So if you stuck it in an exponential, it would say 4 to what power equals 64? You could, or you could think about it with your brain. 4 to what power equals 64? 3. Okay. I know. I'm sorry. I expected you to use your brain today. It's all right. Please forgive me. First I mess up, and then I think that you're going to think. Sorry. Log of 4x minus 3 minus log of x. What do you want to do? How many times do I write log? Is anyone panicking that there's not a base here? It's 10, right? That's a common log. Do I have to write the 10 if it's the common log? I don't. You know it's a 10. It's like understood. Okay? So I write log one time because of this sign. What do I do with these two things? Okay, so 4x minus 3 over x. Can that be simplified? Can you cross out these x's? You cannot. Okay? So some of you just made me very happy. Some of you made me cry. Because we worked on that a lot last year. You can only cancel factors. And 4x minus 3, that's not a factor, that's a number. Right? Factors are things that are multiplied. Remember, this is the silly story I told you last year. I said if you can cancel these x's, then you can also cancel these ones. And you can also cancel this sidebar. So 17 over 19 really is this. That's ridiculous, isn't it? But so is trying to cancel x's right here. Okay? Understand? A little bit? Excellent. 1/2 log of x plus 4 log of x minus 1. If we're condensing, how many times do I write with log? 1. So what? What happens to this? So x to the 1/2. What does this mean? Multiply. What happens to this? Yes? Is that as simplified as I can make it? Yes? I don't know what the computer wants, though. Because it could want this, or, exactly, it could want this. So you may have to end up trying both. Okay? Does that make sense? I think typically it tells you if it wants it in like rational exponents or if it wants something else. But just be careful. Just remember that's true. Okay? 4 log base b of x minus 2 log base b of 6 minus 1/2 log base b of y equals what? So I write it once. Of what? What happens with that? So x to the 4th. What happens to that? It's a squared, right? What's that telling me, though? Divide. Can I skip a step to here? Oh my gosh, I did that in my head without even a calculator. I did. I used my brain. Because I squared my 6, right? Okay. And then where does the y to the 1/2 go? Excellent. Okay, so that's one possible answer. Somebody tell me what the other possible answer is. Got it? How do you feel about expanding and condensing? We good? All right. Last thing is a change of base formula. Log base b of m is really the same as log of m over log of b. And what is the base of these two? 10, right? Now, why would we have to do that? Why would you have to know the change of base formula? Because old calculators only did log base 10 and log base e. Okay? Our calculators do any log base that we put in. Okay? But change of base is important because if you end up with only your phone, can you do logarithms in your phone? If you go to the calculator, you have those choices, right? But if you go to the calculator, you have natural log, which is log base e, and you have log base 10. So if you end up with only your phone, you've got to know change of base formula because it only does e and 10. Okay? Now I know that you all always have your yellow calculators with you. But just in case you don't, just in case you end up with just your phone, we got to know change of base formula. Okay? So if I ask for log base 4 of 7, what is that going to end up being? Log of 7 divided by log of, I always write in the base on accident. Okay? So in my calculator, which I know you can't see, but give me a second and I'll fix it. Log base 4 of 7. Enter. Can you see that? 1.40368, right? 1.40368. 7 log base 10 divided by 4 log base 10, enter. Oh my gosh, it's the same thing. I said, oh my gosh, it's the same thing. Okay? That's why you've got to know change of base formula. Okay? Yes, our calculators do it, but if you end up with just your phone, you can still do this work. Okay? If you know change of base formula. Okay? Any more questions? We good with 4.3? You feel like we covered all the objectives? Let's look over them and make sure, just to make sure. Where's my objectives? Here they are. Product rule. You okay with that? Quotient rule. Power rule. Expanding and condensing. Change of base property. Good?